Back to our introductory uh, into electronics. Radio carrier wave are generated by causing electrons to oscillate rapidly in a transmitter, radio transmitter. Option E. Number 2, which of the following graph represent the graph was given? 3. A semiconductor diode is used in rectifying alternating current into direct current, mainly because allows current to flow only in one direction. Option D. Number 4, in semiconductor, the carriers of current at room temperature are electrons and holes. They are the carriers of current at room temperature. 5, in a pure semiconductor, the number of electrons in the conduction band is equal to the number of holes in the valence band. It's equal to the number of holes in the valence band. Number 6. A transistor functions mainly as a charge storer and amplifier. 7. A transistor is used in the application of signal because it's a semiconductor now. It contains holes and carriers. And remember, an item that contains holes, electrons and holes are called semiconductors. The holes are for the positive, the electrons are negative. Pure silicon can be converted to p-type material by adding a controlled amount of this process actually is called doping, right? In doping a pure semiconductor is made impure by adding a doping material. In doping, a pure semiconductor will be made impure by adding a doping material. Next, right? A pure semiconductor. Write this. To produce a p-type material, trivalent atom, example e.g. boron and indium, are used for doping so that the electron will leave the tetravalent, just end there. I'll go again. To produce a p-type material, trivalent atoms, e.g. boron and indium, are used for doping. They are used for doping. Next, to produce an n-type material, pentavalent, e.g. arsenic and antimony are used. Arsenic and antimony are used to produce n-type. Boron and indium are used to produce the p-type. We'll go further. In a semiconductor junction diode, as the depletion of barrier layer is forward bias, the layer will do what? The layer will narrow. If it is forward bias, the layer will narrow. If it is reverse bias, the layer will widen. You could jot that down also. Yes, it widens, or sometimes they'll say it thickens for the reverse bias, and it becomes thinner or narrows for the forward bias. Then, the major difference between a pure semiconductor and a pure metal is that the resistance of this question will be repeated countless times. The resistance of metals will increase with temperature, while for semiconductor it's the reverse. Their resistance decreases with temperature. Number 11, for semiconductors to have negative temperature coefficient of resistance implies that they have negative temperature coefficient. It means that their resistance decreases. 11, their resistance decreases with temperature. Option D. 12, in a reverse bias junction diode, current flows in few holes and electrons, majority carriers. So in a reverse bias, you get majority carriers. In a forward bias, you get minority carriers. 13, which of the following material is a conductor? Sodium is a conductor. Option B, because it's a pure metal. 14, when impurities are added to a semiconductor, the conductivity of the semiconductor would do what? This one is actually what they call doping. Doping enhances conductivity, so it increases. Option C. 15, which of the following materials is a conductor? We've done that one. So a silicon material is doped with an element of a certain group. An n-type semiconductor is formed. Remember, if you dope, it's like mixing them together, but they call it doping. If you dope silicon with an n with element from group 5, you get n-type semiconductor. So number 15 is option C. 16. In the circuit diagram of a transistor above, the terminals P, Q, and R represent. The terminals P, Q, and R represent B, P. This one might be the emitter. Okay, you get this place be your base, this other place be your collector. 16 is option B. 17. Now, jot down for me. The transistor shown here, you could draw this. Notice where the arrow is facing. The transistor shown here is of the type PNP. Capital letter PNP. PNP. Now, if the arrow were, if the arrowhead faced outward or points outward, that transistor is an NPN. Write it in capital letter. NPN. So, see this one, I call this one PNP. Because this arrow now, see the arrow there. The arrow they face inward. But if it's now outward, the face. Now, if it face outward, now NPN. As it face inside, now PNP. PNP as it's facing inside, like this PNP. The theory of electronic conduction in solid, which satisfactorily explain the properties of conductors, insulators, and semiconductor, is band theory. Option B. 18. A certain manufacturer wishes to make an n-type semiconductor. N-type, you go dope them with waiting, arsenic and antimony. 18. We don't need to go far. Option A. Which of the following represent correctly NPN? Notice it must be facing outward. NPN. If you check very well, because the diagram is not really clear, it's option A. 20. A PN junction diode is used as a rectifier in a circuit. A PN junction diode is used as a rectifier in a circuit. Silicon doped with aluminium and germanium doped with arsenic become silicon doped with aluminium becomes a P-type. Then they say germanium doped with arsenic supposed to be N-type. So 22, P-type and N-type respectively. Option D. 23. The bond that forms a semiconductor is a metallic bond. 24. Zener diode is used for voltage regulation. 25. When a pure semiconductor is heated, its resistance does what? Pure semiconductor, the resistance will what? Decrease. Option B. 25, decrease. But if now it's like, you see wire, we'll do this one much more in the drill sessions. Okay, I wouldn't want this phase so that you come across the equations, maybe you see A, B. You see wire, your normal wire where you take where you wire your house. So if you put that wire, if you put lighter for a part of the wire, come melt the plastic off, come continue to heat the wire. Over time, electricity, now use the word electricity, no go the flow reach your extension well again, because the hotter that wire get, the less is able to conduct electricity. But for semiconductors, the opposite is the case. Now they try to they say for pure semiconductor, heat will do what? Its resistance will do what? Decrease. Meaning for semiconductor, the more you heat them, the more you go fit conduct electricity. But for conductors, the opposite is the case. Next question, they say for current amplification, for voltage stabilization, power amplification as a switch, which of the above is the main use for transistor, Abi? For amplification, for stabilization, and for switch. I think it's saying it's ASS. Option D. Amplification A, stabilization S, and switch S. Option D. 27. Which of the following can conduct electricity owing to the presence of free mobile electron? It's 27 is option D, copper. Pure metals like copper Okay, while semiconductors like germanium and silicon can also conduct, but they have holes and electrons. They have holes as the positive charge and electrons as their negative charge. When a pentavalent impurity is added to a pure semiconductor, it becomes an n-type. Option B. 29. Transistors are used for 29 is option C. If you know C, ASS, which is amplification, stabilization, and switch, just go for amplification of signal, option C. Number 30. This chapter is actually a tiny one. A typical transistor characteristic is represented as one of the following. They don't give us option. 31. Which of the following is a pure semiconductor? Silicon is a pure semiconductor. Silicon and germanium, they are major semiconductors. The bond between silicon and germanium is 32. The bond between silicon and germanium is covalent. Electron sharing, that's what happens between them. 33. Which of the following materials has an increase in resistance with temperature? Increase in resistance with temperature. A metal, option D. That's 33. 34. The electrical property of germanium can be altered drastically by the addition of impurities. This process is called doping. Doping, option B. The P, positive and negative junction diode, can act as a rectifier because they 35. We've touched similar thing like this before. They conduct current when forward bias, option A. 35. 36. If a reverse bias voltage is applied across a PN junction, the depletion layer width is dash. Is a reverse bias, so it is increased. 36. Remember, we say forward bias, it will narrow or tint. Reverse bias, it will widen or increase. 37. Small size, low power requirement, not easily damaged by high temperature, highly durable. Which of the above are the advantage of semiconductor? 37. Small size, low power requirement, not easily damaged, and highly durable, option D. 38. In a common emitter configuration, the output voltage is through the 38. Right. Output voltage equals collector. Input voltage equals the base. Input voltage equals the base. Lastly, the emitter is involved in both the output and the input. 38 is option A. 39. What are the charge carriers in semiconductors? Electrons and holes. 39, option A. Electrons and holes. 40. Which of the following is a semiconductor material? Silicon. 40 is option B, silicon. If you got into this place, you've done well. Well done. I was able to give just a very tiny note, less than a page. Hope you've been able to jot that to snap and send to us on the group. I'm going to leave the link to the group in the description box of this video. If this is your first time coming across our video, please do note we run our sessions for students preparing for both JAMB and also College of Nursing entrance examination. You would like to be part of us, you could also make use of the link and you join us to enroll. Thanks for watching. I'll see you in the next one.